At the end of this video, you should be able to determine the number of significant figures in measurements. Chapter 2, Section 3, Significant Figures. In science, measured values are reported in terms of significant figures. Significant figures in measurements consist of all the digits known with certainty plus one final digit, which is somewhat uncertain or is estimated. For example, in the reported nail length of 6.36 centimeters discussed on page 46 of your text or on the screen now, the last digit, 6, is uncertain. All the digits, including the uncertain one, are significant, however. All contain information that and are included in the reported value. Thus, the term significant does not mean certain. In any correctly reported measured value, the final digit is significant but not certain. Insignificant digits are never reported. As a chemistry student, you will need to use and recognize significant figures when you work with measured quantities and report your results, and when you evaluate measurements reported by others. Determining the number of significant figures. When you look at a measured quantity, you need to determine which digits are significant. That process is very easy if the number has no zeros, because all the digits shown are significant. For example, if you see a number reported as 3.95, all three digits are significant. The significance of zeros in a number depends on their location, however. You need to learn and follow several rules involving zeros. After you have studied the rules in Table 2-5 on page 47 of your text or on the screen now, you can use them to express the answer in the answers for the sample problems that follow in the text.
Rules for finding significant zeros help you ensure that the numbers you report are accurate. Zeros appearing between non-zero digits are significant. We count these zeros when determining significant zeros. Zeros appearing in front of non-zero digits, however, are not significant. We ignore these zeros when determining the number of significant figures. Zeros appearing to the end of the number and to the right of the decimal point are significant. These zeros are only written as part of the number when they are significant. Zeros to the left of the decimal place, however, have to be written whether or not they are significant in order to designate their place. If you measure exactly 200 milligrams of a substance, then the zeros in this number are significant. If, however, the zeros are just placeholders to indicate 200 milligrams as opposed to 100 or 300 milligrams, then the zeros are not significant.
Rounding. When you perform calculations involving measurements, you need to know how to handle significant figures. This is especially true when you're using a calculator to carry out mathematical operations. The answers given on a calculator can be derived results with more digits than are justified by the measurements. Suppose you use a calculator to divide the measured value of 154 grams by a measured value of 327 milliliters. Each of these values has three significant figures. The calculator would show a numerical answer of 0.470948012. The answer contains digits not justified by the measurements used to calculate it. Such an answer has to be rounded off to make its degree of certainty match that in the original measurements. The answer should be 0.471 grams per milliliter. The rules for rounding are shown in Table 2-6 on page 46 of your text or on the screen now. The extent of rounding required in a given case depends on whether the numbers are being added, subtracted, multiplied, or divided.
Rounding rules help you ensure that the significant figures you report in a measurement or calculation are accurate. Once we find the digit following the last digit to be kept based on the rules for significant figures, we ask the following questions. Is this number greater than 5? If so, we round up. Is this number less than 5? If so, we round down. Is this number equal to 5? If so, we have more questions to ask. Is the next digit after the 5 greater than 0? If so, round up. If the next digit after the 5 is 0, then look at the digit before the 5 and determine if it is even or odd. If it is odd, round up. If it is even, round down.
At this point, you should be able to determine the number of significant figures in measurements.